Today we're going to look at a second strategy that we can use when we're solving equations involving fractions. This second strategy is called cross multiplication, and it can be helpful under certain circumstances when the equation contains fractions that are isolated, one fraction on one side of the equal sign and another fraction on the other side of the equal sign. Let's look at some examples so we can see how this works. To understand how cross multiplication works, we need to look at some of the properties of equivalent fractions. So if we look at a fraction like 2/4, we know that we can change it into 4/8 by multiplying the numerators by 2 and the denominators by 2. What this ultimately does is it multiplies 2/4 or 2/4 by 1 whole. We talked about this in Unit 1. Now, another property of equivalent fractions is that the numerators and denominators are also related by the same factor. So if I were to multiply the 2 by 2, I would get the 4 of the denominator. And on the other hand, if I were to multiply the 4 by 2, I would get the 8. A third property of equivalent fractions is that if we look along the diagonals, those also will be equal. So in this case, 4 times 4 will be equivalent to 2 times 8. In both of those cases, you're going to see that you would have 16. This is an important property to understand as we cross multiply because it's what makes it work. So for cross multiplying to be an option in a question, we need to have the question set up so that it has a fraction on one side and a fraction on the other side. This is true in this case, so we can look to cross multiply. We would be multiplying these items together, and then we would be multiplying these items together. Ultimately, what that's going to do is it's going to create us a situation that looks like the distributive property. So on one side of the equal sign, I would write this, the green diagonals multiplying with each other. And on the other side of the equal sign, I would write this, where it is the blue diagonals multiplying with each other. At this point, we'd apply the distributive property like we did in previous lessons, and we would simplify to isolate the variable. If you can't remember how to do this, make sure you look back at the previous videos about how to solve an equation involving the distributive property. Cross multiplying also works when the variables are in the denominators in an example like this. In fact, cross multiplying would be the only way that we know how to solve an equation that looks like this one. So once again, we would be drawing our diagonals. We would be multiplying the 6 by the 2x across the blue diagonal, and across our green diagonal, we would be multiplying 3 and then 7x minus 1. Once again, we would have to apply the distributive property on the right-hand side. The left-hand side would just simplify to 12x. And then we would do the distributive property on this side like this. Once again, you know what to do from here. You would bring the 21x over to the left-hand side in order to isolate the variable terms, and then you would have to look at what the new coefficient would be of the variable and divide by that, just like we've done in the past. So just a reminder that cross multiplication only works when you have an equivalent fraction equal to another fraction. So in a case like this question, where only the left-hand side looks like a fraction, you would need to look and see if there would be a way to make the right-hand side also look like a fraction. In a case when it's a whole number, it's just a matter of adding a denominator of 1. If we put that denominator of 1 in place, then we can go about doing the cross multiplication by multiplying diagonally across the equal sign. So if we were to do this question here, we would wind up with 1 being multiplied by 4 and then the 3x minus 1 on the left-hand side. And on the right-hand side, we would do the 6 times the 2, which would give us 12. At this point, we would need to follow what we know about BEDMAS, and before we could multiply into the set of brackets, we would want to simplify this coefficient here. So we would wind up doing 4 times 1, which would be 4, and then we could multiply with using the distributive property with what's inside that bracket. Note that this is a little bit of a change in some of the questions that we saw earlier in the year where this symbol here at some point was an addition sign, and we knew at that point that following BEDMAS meant we'd have to distribute first. But because in this case, this 1 times 4 is outside of the brackets, we would use BEDMAS to say we would do this multiplication before we would do this multiplication because it's what appears first from left to right. In an example like this one, the same thing can apply, can put this second fraction over 1 so that I then have a numerator and a denominator to multiply diagonally on both sides. I hope this will be helpful to you as you start to try some of your homework questions. Don't forget that if you have any concerns or anything that you can't work out by yourself, to make sure that you contact me. You can email me or you can add a post to the discussion board. In either way, I'd be happy to answer your questions. Take care. Enjoy your day.